today's class, we are going to understand that how different kinds of motions looks when we see through a graphical presentation. Means when we express different types of motion, state of motion like rest, uniform motion, non-uniform motion with uniform acceleration, or non-uniform motion with non-uniform acceleration, then how the mathematically, graphically the things looks like. So to get a graphical presentation, what we do, we have two different categories. One in which we express how the distance varies with respect to time, and on the other hand, in second category, we'll come to know how speed value changes as time passes in these four different situations of motions. So, what is our today's topic? Distance time graph. First period, what we have to understand, how according to time variation, the distance of an object from the observer changes. So for that, we have taken again the straight path, and suppose the very first situation which we are going to understand under distance time graph situation is rest. As per definition of rest, we know that we take any object with respect to any other object, that is observer or point of reference, and if we see no change in position of the object with respect to observer as time passes, then we say it is a case of rest. So for example, here I have taken a situation in which a person is standing 5 meters away from the observer. Okay, so somebody is there which is 5 meters away from the observer. Suppose I am the observer and somebody is there at 5 meters away from me. Now when I will start observation, so I will note down the distance, position of that particular object with respect to time. So suppose when I started my watch, that means the time taken will be 0. So suppose what I am observing here at 0 second, that means when my watch has started, the person is at 5 meter. So 0 second, 5 meter, 1 second, 5 meter, 2 second, 5 meter, 3 second, 5 meter, 4 second, 5 meter. So what are you observing? The time is passing, but the position still remains same as per definition of rest. This is the correct situation. Now, with the help of these tables, with the help of mathematical notation of graph, we are going to represent on a graph paper. So you will have a graph paper, so you will use that. Now how to draw this graph on the graph paper, that we are going to understand. First of all, we will draw two mutually perpendicular lines over each other. This line, which is mathematically called x-axis, and this is called y-axis. So on this axis, we will divide this line and we will represent time on this. And on this vertical axis, which we call y-axis also, we will take distance. Now, to show the time, I have divided this axis, which is horizontal now, in different parts by showing, like this is showing 0 second, 1 second, 2 second, 3 second, 4 second, 5 second, and so on, as long as the observation is being taken. And on this, when we are taking on vertical line, we are taking the distance of the object with respect to observer. So here for this vertical line, y-axis, this 0 is showing 0 meter. Please take care of that. For this line, it is showing 0 second, and for this axis, this line, we take it as a 0 meter. Now when we are showing this 1, so actually 1 meter. So I have written here distance in meter and here time in second. If the unit is taken second for time and time for meter for distance. If you take hour, you can take show in hour also, and this can be in the kilometer also. So it depends on you. But according to our situation, this is second and this is meter. Now, so 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter, 7 meter, and so on. Now, how to express this points taken on a graph. So it's a very simple step. Now I have made a point. Here I have shown 0 second, 5 meters. So time first and its position. 1 second, 5, 2 second, 5, and so on. Now, according to rule of mathematics, first we take the value on horizontal line that we call x-axis. So for this, for ourselves, this line is acting as a time axis, and this is acting as a position axis, so distance axis. Okay. So now, how will I show it? 0 second, 5 meter. So 0 seconds. So first we'll move on horizontal line. Since it is 0 seconds, so we'll start from here, and then this 5 meter we have to go on vertical line. So this vertical line. So we should not go this side. This is for time. So time is already 0 second. So 5 meters. So 5 meter will be somewhere here. So I have just shown 0 second, 5 meter. Now what about next? 1 second, 5 meter. So which one should be selected? This or this? So as I said, this is the 1 second. This is 1 meter. So better what we take? First we take time. So 1 second. And how much is the distance from the observer? 5. So 1 second. Again we will rise to vertical line. Vertical distance, that is 5. So how will I show the point? 1 second, 5 meter. Then 2 second, 5 meter. So this is the 2 second and 5 meter. So I will again rise up 5 meter. Then again 3 second, 5 meter. 4 second, 5 meter, and so on. So when I am getting these points, and if I am joining this, I am getting a line graph. I am getting line graph which is running parallel to the time axis. So what kind of graph we get when we see when we analyze rest situation? A line graph parallel to time axis. So this is one of the basic features. So whenever you see any graph and whenever you see somewhere the line is going parallel to time axis, that means that particular part is showing a situation of rest. Now why it is passing at a distance of 5 unit? Because I have imagined that the observer and the object are 5 meter apart from each other. Now suppose for anybody who is at 3 meter. So what will be the change in the graph? The graph will be still line graph, but it will not pass 5 meter apart from that observer. So how will we show this? It will be parallel only, but from at a distance of 3 meter. So it will go like this. Suppose somebody is at 10 meter. So it will be somewhere parallel to the time axis, but at a distance of 10 meter or 10 unit. So this is the way in which we express the situation graphically when the body is at rest. So what is the conclusion? It comes a line graph parallel to time axis.